All right, let's continue from where we stopped. So if you look at class A, I order bit is 0. First octet address range. Many of you will be familiar with this. 0217, 127. 0 to 127 is for class A. Yeah, number of bits in the network address, number of bits, 8. Remember, 24 hosts and 8 network. Number of networks 126. 2 to the power of n, 2 to the power of 8. You will get 128 minus 1. You will get 127. Normally the one address 127 we don't use. So you will get 126. Whereas number of hosts 2 to the power of 24 minus 1. You will get 60 million hosts. That's more than enough. There is a known network in this world today having 16 million hosts. No, those are the days. Today, even Google, like what we know, is the most active ISP or service provider. They might have hundreds or thousands of hosts. That's it, worldwide. I don't think so. They run into millions. But when you combine the entire hierarchy, that means US, with all the countries throughout the world, the number can be quite big. But again, I don't believe into millions. But that is the capability of that class A. Class B, maximum 65,000. Class C, 254. 2 to the power of n minus 1. That's more than enough. 255 is the maximum. 255 is the maximum, minus 1 is 254 because it's from 0 to 255. And the range of IP address is 192 to 223. And most of the network, we are here. We are here. If we use what we call private IP address, yeah, we are here. 24 bits number of network and 24 bits number of 24 bits of number of network, 8 bits number of server or host. That's more than enough. D and E are for different purpose, different purpose. So normally we don't see company network on D and E. D for multicasting and E for research. So this the range are again down here, as you all can see, and also they have converted in binary for your information. Okay, more example which we already discussed earlier. This is for class A. The first one is class A because the first bit is 0. This is a class A address. This is network, this is host. And then the first 2 bits are 1 over here. And the third bit is 0. So this is class C, class C address. And then the next one is first bit is 1. The next bit is 0. That is class B. This is the easy way to identify which class they belong to. But again, when you see the IP address, normally you will see the range. You don't see the IP address in bits. You will see the IP address like this. So when you see the IP address in this decimal format, you know whether they are class A, B, or C quite easily. You don't see the IP address like that. You see, when it is all 0 or when it start with 0 is class A. When it start with 1, 0 is class B. When it start with 1, 1 is class C. But normally, like what I said, we don't see your IP address in this format. We see your IP address all in numbers. So when you see numbers 192 dot something something, you know it is class C. 128, 132, for example, 191 is all class B, right up to 191. 192 class C. That's how you identify IP addresses, not by using bit. Bit is for machine, for the computers. So don't worry much, but anyway, you need to know. Even when you work, you don't use bits, too complicated, too difficult. We always use decimal like this. Yeah, decimal, easier. So you know this is what class, this is what class, easier, easier to remember. Okay, you see this is easier to remember, isn't it? You remember the range, you know which class it belong to. Class D, class C, class B. A, 0 to 126 A. Yeah, this is 252. So class D. Class E, 252. Okay, so this is much more easier than referring to bits. Okay, next slide, going to explain to you about the NAT ID and host ID, which you already discussed in the first slide itself. Number of bits for network ID and number of bits for host ID. So please, you go through this. All these are another way of presenting the IP address. Yeah, 32 bits, N bits network and host ID. The differences are in terms of N, isn't it? This is what we discussed earlier. And the formula that you're going to use is 2 to the power of N. You minus 2 reason, the first one is 0, the last one is you don't use. Like 127, we reserve. We use it for loop. So you minus 2. Because some student might ask me a question, why minus 2? Why not 1? For that reason. Okay, there are some examples here which I'm not going to go through. Reason you can go through this on your own, it's quite easy. Or you can do it during your tutorial class with your tutor, local tutor. And we will have more during the past year questions discussion. We have covered all this, in fact, earlier. Another example using graphic format, the IP addresses, how the IP addresses are connected to the switch. Example 2. Yeah, another example of class B. Yeah, because it starts with 180. 180, you know, it's class B. Another example, class C. 192, it start from 192, so class C. The range is 191 right to something, isn't it? So you know 223. Yeah, 223. So you know this is class C. 24 bits of network and 8 bits of host. So reserve IP address, like what I mentioned earlier, some IP addresses are reserved for certain function. For example, for broadcasting, for multicasting, and so on, for loop uh, check, and so on. Loop back check, and so on. That's what we call reserve IP address. Which is more interesting to discuss is the private IP addresses, where due to popularity of TCP/IP, and we are running out of the actual public IP address version 4, the organization who are responsible for IP address management have come out with what they call private IP addresses. Private IP addresses, which are also, they use the same class A, B, and C. But now the range are different compared to the private IP compared to the public. I'm very sure all of you have seen this during your diploma or foundation. Nothing new, just matter of different range. If you see the numbers start with 10 or 172 or 192, very short range. Then they are private IP addresses A, B, C. Classes are the same, but the range of the IP address and the numbers they use. RFC means request for change or request for it's an internal code for some request to do some changes. Network address translation, NAT table, is where all the network addresses will be kept for the networking purpose. It's a network address translation. It's a table. It's a table. It's a soft copy where the network OS will keep it for references. All right. For example, you have company X need to communicate with company Y. So it has to go through number of routing. This is company X IP addresses. All are private, private class A. This is company Y. You see, company A and company Y, they can use their own and same IP address as company X. No issue because they are private. They are only known to this company X. IP addresses Y only shared within company Y. They cannot share or they don't share between X and Y. So they can have same IP address. In public, you cannot do that. In public, you cannot do that. You will get IP address conflict. Within the same company, you cannot have same IP address as well. And all this information will be kept in the routing table. We call that NAT table, which is inside the router. You see the NAT table will be like this. The NAT table will keep the public address and private addresses in the table. So if you from the private, you want to go into the internet, you know what are the addresses to refer to and vice versa. Because if you go through the gateway to your public addresses, then you need to communicate with the public proper class so that you get the information that you're looking for. If you don't have your server here, if your server is outside on the internet, you have to go to the internet. Port address translation, same like earlier, NAT or network address translation, but this keeps all the port numbers. Instead of the network addresses, this table keeps all the port numbers, which port. These ports are quite complicated as well. It's not as easy as what you think. It could be the port at every devices. You see, these devices will have its own port number. Remember, we discussed about email use different port number, internet use different port number, FTP use different port number, and then when they are on a different devices, on a different IP addresses, then it can get complicated. So you need a table to keep all this information so that the communication take place. For example, if you launch the browser, then the appropriate port number will be activated, and then which device need to connect to which device. That's where the IP address comes in. Either it is private or public and will be communicated and working accordingly. So for example, let's say this client here, there are two clients here, IP clients, .1 and .2. They need to communicate to the internet. They will first look for the switch. From the switch to the router got a NAT table, networking or network addressing table, also the port addressing table. Both will be inside the router, and then the router also will let you know, hey, where is your gateway? Then the gateway address is 198.60.123.100. If this router is connected to internet, that's how you're going to go through to the internet and vice versa. Example of port address is up here, 10.0.0.1, and then follows with the port number 2562. These numbers varies, depends on the services, and also it will have sub information, depends on what services or what other devices that you use. And this is a public address with the phone numbers. So just to share with you, if you guys want to learn about IP addresses, you don't think this IP addresses is not that is that simple, huh? When I did cover IP addresses, I spent 5 days attending courses with with the training providers just to learn about IP address. It can get very complicated. It's very technical, huh? It's very technical. It's not as what you see. It's not as easy as the four numbers here. We haven't discussed about sub IP address, subnet mask, the algorithm involved in calculating how many network that you can have, how many hosts that you can have, how many network that you can have, what are the ports, what are the port numbers, and so on. It will easily take you 5 days just to cover one section. So that's why once you are qualified as a CCNA certified network engineer, you are really good. People really respect you, and your salary will be very, very high. Yeah? You will be in very high demanding position. So Cisco qualification or Cisco certification is still very highly demanded. In a company, normally there will be either one or two network engineers only, and they will take care of everything. Yeah, the entire company's network are depending on them. So that's the reason why they're very highly demanded, very highly skilled, trained people compared to programmers. Programmers, you can have many. You may have 20, 30 programmers, and many of them know each other's. I know C, you know C, I know Python, you know Python. But when it comes to networking, there will be very few people knows everything. So very much we are depending on one or two guys. To make things worse, or on the other side, to look at the positive side, to make it more interesting, today's networking people are also good in security because they are two in one. So as you all know, networking and security and cyber security are getting very hot because without these people, I don't think so anyone dared to operate. Even I got to know 2 days ago, University of Sunderland, things like that. For example, I need to verify the information. For example, it happens to other network owners as well, where systems got hacked easily. Yeah, with the advance of technology, the hackers are holding today, or with the knowledge that they have today, they can hack into any network within seconds or minutes in order to get information, whatever information they want. So people, those who knows networking and security are very highly demanded, and they're very highly paid. But because they are very highly skilled and technical peoples. All right. So let's look at this slide here. There is one example. It is actually a UOG, UOG LAN, local area network. So the question I believe is, it is possible to have two PCs at different institution with the same IP address, like what I told you earlier, isn't it? Two private network can have same IP address. So you see on the left hand side and on the right hand side, this is you have UOG over here. You have another university. Over here, the IP address is 192.168.78.45. Over here also the same. So this is possible because this is one private IP address, this is another private IP address. They are different entities. So as long as they have their own private IP address, you can have same IP address within the two companies. But within this company, you cannot have two IP addresses. Two similar IP address, you will run into conflict. Okay, ask me if you have any questions or clarification. Further clarification required. Otherwise, I will assume that all of you understand. Okay, we're going to move on into subnet mask. Maybe not very detailed because subnet mask is much more detailed than the IP address itself. IP uses a subnet mask or what we call network mask to determine which part of the address identify the network portion, either all ones, and which part identifies the host portion, all zeros. Either it is we need to identify which network that subnet mask belong to or which network the host belong to. Subnet mask looks like IP, same like IP, 32 bits, a dot every 8 bits. Quite similar, but the range are different. The range are different. For example, for class A, the range starts from 255.0.0.0. For class B, it starts with 255.255, 24 bits. Over here, 24 bits, over here 16 bits, over here 8 bits. So that's how the subnet mask is compared to IP address. And most of the time we will use class C. So it's quite easy, 255.255.255.0. Yeah, dot 0. And as you know, class C can have 254 hosts. That's more than enough for any company today. Like what I told you earlier, there is no company holding more than 100 servers nowadays. Very hard to see. Those days, yes, not today. Yeah? Okay, that's an example of subnet mask. So you have network portion and host. Yeah, for this class B, where the IP address is 153.92. And the host portion is 100. Because this is host, this is network. Common subnet mask, some common examples. Yeah, this is class C, most of it class C. Yeah, this is okay. All these are class C. This is class B. So it depends how you look at it. NetBit, this is 30. Either you put /30 or you write it this way. It's the same. Two usable hosts, that means 253 and 254. Two hosts are available, the rest are not. So that's how. But once you are experienced with all these subnet, you don't write in this format. You write in this format. /30 means you know it's a two hosts. /29 you know is what we call 6 usable hosts because the IP address is 248. So 248, you have 249, 50, right up to 54, 6. So the more hosts you need, you just play around with the IP address, then you put the slash. Yeah, that's how you see. It all depends on number of hosts. Okay, international routing is another new router or new routing table that will be introduced for the networking, but not a common one. Not a common one. This is for international, classless inter-domain routing. That means here there is no class. Yeah, no class, but just for inter-domain routing from domain to domain, routing from domain to domain. For example, you want to route from Microsoft.com to Google.com. That is what we call inter-domain, uh, intra-domain routing. But when you do routing internally within Microsoft or within Google, you call it inter-domain routing. For that, you need this protocol. Yeah, for that, you need this protocol. One example that you can see on this slide is the network and host. Yeah, demarcation can be made with any number of bits from the beginning of the address. For example, they use class C here, 192.203.187.0 and /26. This /26, like what you see here, is the subnet mask 255.255.255.192. They wanted maybe up to 60 number of usable hosts, so they put /26. The more hosts you need, you got to reduce these numbers, meaning you give more hosts to the network. Okay, so this is an example of how you do inter domain routing within the same network. Subnet mask, again on subnet mask, but from all the passive questions that I have seen, they don't go into this much of detail when they set the question. But it's good for you to understand, good for you to know how they calculate, yeah, subnet mask and the meaning of the subnet mask, but not this much of detail for your case, because you're just in year one. You don't have to go into very detail. There are some logic involved here in the subnet mask calculation. Like I told you, it will take 5 days for you to fully understand how the subnet mask works. Example, this is on AND gate, AND gate or AND operation. They will take the destination address and then they will take the default subnet mask in order to calculate the network address. That's how it works. It's not SUC, it's not SUC. It takes the destination address, add with the subnet mask using AND gate. AND gate means add in order to get the new network address. That's how it works. So it's quite complicated, not as easy as you see. Yeah, and it can be very confusing to get the network address, to get the result. All right, subnet mask, again on subnet mask, the formula that we use is 2 to the power of n. I can skip some of this because it's really complicated and I don't want to confuse you unless you go for a higher training, or there is no other network subject except there is one subject in year 3, which we will go through all this partially and then there will be more detailed discussion. Otherwise, for this course, the requirement is only for you to understand the basic. For example, the question here is, what is the network address of this IP address? So first of all, you must know which class it belongs to. So this is class B. So class B uses subnet mask of 255.255.00. So if you follow to that format, it should be 144.124.0.0. Yeah. So what is the network address? This is how you calculate 144.124.15.117 class B, class B. Yeah, class B. Remember class B. So if you check it out, for example, 22, yeah, slash 22 slash 22, they're asking you class 22 because here you can go maximum 24 bits. Yeah, such as this, for example, slash 22 is 252.0. Sometimes you have to know that. After some time, you will familiar with all this now, what is 22 and so on. But normally we don't use all this too many hosts. We don't need that. So if you convert this into binary, this is how it looks like. 255, 255, 252, 0. This is equivalent to slash 22 class B, subnet mask for class B. And then you got to do the addition. Remember the address, destination address plus the subnet mask. So this plus the subnet mask, you got to total it up. So it involves some calculation, you got to total it up. So when you total it up, this is what you get. So the new IP address will be 144.124.12.0. After you adding 0, you add everything. You add means you follow this logic, AND gate. 1 and 0 is 0, Yeah. Don't add like what you add mathematically. That's different. This is logic gate, logical AND. So you must remember this formula. 1 and 1 is 1, 1 and 0 is 0, 0 and 0 is 0. So don't ask me why 0 plus 1 is 0, because this is logical gate, logical AND. Not a direct mathematical calculation. This is using logical gate AND. Or in other words, sometimes you convert this into true and true is true. True and false is false. False and false is false. That's how it works. Okay, there's another example here. You can play around with it, or during the tutorial, you can also try this. The value is slash 27. The value of n is slash 27. Subnet mask is 27, 1 and 5 zeros. It is, because you have 27, 1. This represent 1, isn't it? Same as this. 22 means it 22, 1. Yeah. And then there are all zeros out of 32. So 27 means put 27, 1. And the rest all zeros. Total should be 32. So if you calculate, you will get IP address, for the subnet mask 255.255.255.224. Yeah, which is also in this table. If you can refer to this table. Where is the table? This table. Okay. 27. And there are 27, 1 and 5 zeros, which allows you to have 30 usable hosts. 2 to the power of n. Okay, so this is the original IP address, subnet mask, this one, the totalita we get this. So this is the new IP address. So that's why I say the subnet or the new address calculation can be very complicated, not as easy as we see. It has its own mechanism to calculate. That's the reason why you have IP address and subnet mask. Yeah, subnet mask. Okay, there are more examples which I'm not going to discuss here. We are running out of time. You can discuss all this during your tutorial sessions. Why subnet? More examples of subnet mask. So your local tutorial maybe can go through all this with you if you are interested. But like what I said, normally they don't test all this in the exam. I have not seen this complicated calculation yet in your exam paper. Okay, so time is almost going to be 5. We have only few more slides, which I'll try to finish it by today, so that we can do revision in the next classes. Why subnet? Please read through. Makes more efficient use usable of available IP addresses. Enable dividing network into logical group, so we can have different logical group. For example, we can have accounting group, HR group, uh, lecturers group, marketing group. Just with IP address is a very difficult. So when we have a subnet mask, different subnet mask with different subnet with different IP address, it allows you to have different logical group, or not physical group, logical group. Subnet also helps to reduce broadcast traffic. So when you have isolated or different group, it allows you to have different or lesser traffic. Okay, the same example, take a look. Operation of IP address, ARP, the common one, address resolution protocol. This is to solve your IP addresses. Implemented a network layer so that ARP is part of your OS in order to resolve IP address for the network. Yeah, so please read through ARP, address resolution protocol, how it works. Yeah. It uses some formula or mechanism to resolve the IP address. So technically, it's quite technical. So I don't want to run through with you, but there is a very simple graphical explanation just to make you understand. Obtaining an IP address, which you guys are quite familiar with, either we can have static or dynamic. It's up to the administrator of the local area network to decide whether you want to go for a manual, static configuration, or dynamic based on DHCP. If you have a DHCP server in your organization, your IP address can be configured dynamically. Otherwise, you manage it manually. Static, yeah? It's up to the local network administrator. Okay, so with that, I think I have covered the network classes. if you see, we have covered all the chapters from the beginning on OS and network. So this Friday, no class. When I see you on next Tuesday, we will do revision. Yeah, we will do revision, and also I'll upload the rest of the videos which are missing from here, so that all of you can download and go through it. I will try to upload on both sections, on MS Team and also in YouTube. Okay, with that, let me go back to the meeting. If there is any questions that you like to bring it up or highlight, please let me know.